immune response, this specific reactivity induced in a host following an antigen stimuli is known as a immune response. Immune response is of two types: humoral or antibody mediated immunity and cell mediated immunity. The antibody mediated immunity provides a primary defense against most extracellular bacteria and helps in defense against viruses those infects though through respiratory or intestinal tract. The antibody mediated immunity also participate in the pathogenesis of immediate type 1, 2, and 3 hypersensitivity and certain autoimmune diseases. The cell mediated immunity protects against fungi, viruses, and intracellular parasites such as leishmania and trypanosomes. It plays an important role in allograft rejections, graft versus host reactions, and mediates the pathogenesis of delayed type 4 hypersensitivity and certain autoimmune diseases. It also provides immunological surveillance and immunity against cancer. Both antibody mediated immunity and cell mediated immunity usually develops together, though at a time one or other may be predominant type. Humoral immune response, the production of antibody. The antigens are present to the immunocompetent cells by antigen presenting cells, APC, macrophages, and dendritic cells. When the process antigen is presented on the surface of antigen presenting cells in association with the MHC complex to the T cell carrying antigen recognition receptors, is the T cell able to recognize it? The T helper cells requires two signals for activations. The first is a combination of T cell receptors with the MHC class 2 complex antigen. The second is interleukin 1 produced by the antigen presenting cells. The activated T helper cells produces interleukin 2, and the other cytokines requires for B cell stimulations. The B cell undergoes clonal proliferation and differentiate into plasma cells that synthesize and secrete antibodies. A small portions of B cell develop into memory cells which have a long lifespan and can recognize the same antigen on the subsequent exposure. Theories of antibody formations. There are two broad groups in instructive theory: direct template theory, indirect template theory, and selective theory, side chain theory, natural selection theory, clonal selection theory. The instructive theory postulates that an immunocompetent cells ICC is capable of synthesizing antibody of all specificity. The antigen instructs ICC to produce the complementary antibody. The selective theory, on the contrary, postulates that the ICC have only a restrictive immunological range. The antigen selects the appropriate ICC to synthesize an antibody. Clonal selection theory. The clonal selection theory is widely accepted nowadays. This theory says that during the fetal development, a large number of clones of immunological competent cells ICC bearing specific antibody pattern are produced by a process of somatic mutation of ICCs against all possible antigen. The clones of the cells with the immunological reactivity with the self antigens are eliminated during the embryonic life. Such clones are known as a foreign clones. Each ICC is capable of reacting with one antigen. The contact with the specific antigen leads to cellular proliferation to form a clones synthesizing the antibody. Monoclonal antibody. The antibody that are usually produced in the response to a single antigen or synthesized by several different clones of cells, that is polyclonal. The single antibody forming cells or clone produce antibody that against a single antigen or antigen determinant only, and such antibody are called monoclonal antibody. The method for production of monoclonal antibody against any desired antigen was first prescribed by Kohler and Milstein in 1975. They were awarded Nobel Prize for Medicine in 1984. Techniques. The antibody forming spleen cells are fused with myeloma cells to produce hybrid cells, hybridomas. The resultant hybridoma retains the antibody producing cells of spleen cells and ability of myeloma cells to multiply indefinitely. Applications. Diagnostic uses. Many commercial diagnostic systems are used monoclonal antibody for identification of bacteria, viral, and other antigens. Direct direct fluorescence and enzyme linkase utilizes monoclonal antibody conjugates the pure antibody. The large amount of pure antibody of defined classes can be prepared. Cell-mediated immune responses. The term cell-mediated immunity refers to a specific acquired immune responses mediated by sensitized T cells. This form of immunity can be transferred from donor to recipient with intact lymphocytes, but not with the antisera. Hence, it is called cell-mediated immune reactions. The cell-mediated immunity plays an important role in the following immunological functions: delayed hypersensitivity, type 4 hypersensitivity, immunity in the infectious disease caused by the intracellular organisms, the transplantation immunity and graft versus host reactions, immunological surveillance and immunity against cancer, pathogenesis of certain autoimmune diseases. Introduction of cell-mediated immunity. The foreign antigen is presented by the antigen presenting cells to T lymphocytes. The T lymphocyte possesses antigen recognition receptors known as T cell receptors TCR that recognizes foreign antigen and self-MHC molecules on the surface of the antigen presenting cells. These sensitized T lymphocyte undergoes blast transformation, clonal proliferation and differentiation into the memory cells and effector cells. The activated lymphocytes releases biologically active product lymphokines which are responsible for various manifestation of cell-mediated immunity. Cytokines. These are biologically active substances secreted by monocyte, lymphocytes and other cells. They are named lymphokines if they are derived from lymphocytes, and monokines if they are derived from monocytes and macrophages. The interleukins are chemical substances that functions primarily as a growth and differentiating factor. They exert a regulatory influence on other cells. All these biologically active substances, lymphokines, monokines, interleukins, are collectively known as cytokines. They are not specific for antigens. Various cytokines and their functions are shown in the figure. The direction of cell-mediated immunity. The cell-mediated immunity can be detected by the following method: skin test for delayed hypersensitivity, detection of T cells by immunofluorescence technique. So, interleukin 1 major source macrophage monocytes. Main function: stimulus T cells for the production of interleukin 2 and other lymphokines, B cell proliferation, neutrophils and chemotaxis. Interleukin 2 major source T cells, major activator of T cells and B cells. Cytotoxicity of T and NK cells helps in destruction of tumor cells. Interleukin 3 T cells acts as a growth factor for bone marrow stem cells. Interleukin 4 T helper cells, proliferation of B and cytotoxic T cells, augments IgE systems. Interleukin 5 T helper cells, proliferation of activated B cells. Interleukin 6 T B cells, macrophages and fibroblast. Induction induces immunoglobulin synthesis by the T cells, formation of interleukin 2 receptors on T cells. Interleukin 7 spleen, bone marrow, stromal cells, B and T cell growth factors. Interleukin 8 macrophages, neutrophil chemotactic factor. Interleukin 9 T cells, proliferation of T cells. Interleukin 10 T B cells, macrophages, inhibits interferon productions. Interleukin 11 bone marrow stromal cells, induces acute phase proteins. Interleukin 12 T cells, activate natural killer cells. Interleukin 13 T cells, inhibits the function of mononuclear cells. Interleukin 14 T cells, stimulates the proliferations of activated B cells, inhibits IgG immunoglobulin secretions. Interleukin 15 monocytes, proliferations of T cells and activated B cells. Interleukin 16 eosinophil CD8 plus T cells, chemo attraction of CD4 plus and cells. Interleukin 7 CD plus T cells releases interleukin 6, interleukin 8, GCF and PGE2. Interleukin 18 hepatocytes, induces interferons gamma productions, enhances natural killer cells activity. Colony stimulation factor GCSF, MCSF, fibroblast endothelium, granulocyte growth stimulation, mononuclear growth stimulations. Tumor necrosis factor TNF alpha. Main functions: the tumor cytotoxicity, antiviral effect, endocytic effect, tumor necrotic effect beta induces other cytokines, interferons, alpha interferons, antiviral activity, and beta interferons, antiviral activity, gamma interferons, antiviral macrophage activations, increase the cytotoxicity of natural cells.